Okay, 7th grade, here we go again. Page 285, perimeter and area of triangles and trapezoids. Page 285. Okay, so in the previous lesson, perimeter and area of quadrilaterals, we defined perimeter as the distance around the outside of a figure. So if we look at example 1, they are asking us to find the perimeter of each figure. Notice, part A, we have a triangle, 3 sides, and part B, we have a trapezoid, okay? Remember, by definition, a trapezoid is a quadrilateral with one pair of parallel lines, just one pair. In this case, those parallel lines will be the basis of the trapezoid. Now, in part A, we have a triangle with 3 sides. Side with this side measures 8, 14, and 10. So, perimeter is equal to 8 plus 14 plus 10. 8 plus 14, that's 22, plus 10, that's equal to 32 units. Okay, that would be the perimeter of triangle with measures 8, 10, and 14. Now, for the trapezoid, part B, we have 4 sides, 2, 11, 4, and 7. So perimeter, in this case, will be equal to the sum of 2 plus 11 plus 4 plus 7. Okay, 2, 11, 4, 7. So we add 2 plus 11, that's 13, plus 4 plus 7. 13 plus 4, that's 17 plus 7. 17 plus 7, that's 24 units. Okay, so that will be the perimeter for the trapezoid and the perimeter for the triangle. Okay. Now, notice that a triangle or a trapezoid can be thought as half of a parallelogram. Okay? If we trace a diagonal that goes from this corner to this corner, notice what happens. Now that we have traced the diagonal, notice that a triangle is half of this parallelogram. We have 2 triangles. I'll call this triangle A and I'll call this triangle B. Now, triangle A is 1/2 of this parallelogram. Okay? Now notice for part B, for the second parallelogram, if I trace a diagonal, a line that goes from this point to this point, notice what happens. Notice, once we trace a line that goes from this point to this point, that we have created 2 trapezoids. Trapezoid A and trapezoid B. Okay? So, from this, we can say that, by definition from the previous lesson, we learned that the area of a quadrilateral was equal to base times height, right? So actually we were talking about the area of rectangles and parallelograms, right? Well, so here if we want to find the area of this triangle, the area of the triangle, then we can say that the area of this triangle is 1/2 the area of the quadrilateral. And that's how we get the area of a triangle. Now, in the second part, notice that we have two parallelograms. Parallelograms have two bases, okay? So it is similar to the area of trapezoid is similar to the area of quadrilaterals and triangles, with the difference that it is area equals 1/2 the area of the quadrilateral, right? So in this case, it will be 1/2 the height times the sum of the two bases, base 1 plus base 2. So this is how we can derive formulas for the area of a trapezoid and the area of triangles using the previous knowledge we had from the lesson before about area of parallelograms and rectangles. Now, using what we learned before, we can define the area A of a triangle is 1/2 of the base, 1/2 of the base length B times the height H. Don't forget that for triangles and for parallelograms, the height is always perpendicular to the base. Perpendicular lines forms or creates right angles, okay? So this will be our height for the triangle. So area equals 1/2 base times height. Now, area of trapezoids. The area A of a trapezoid is 1/2 the height H times the sum of the base lengths B1 and B2. 1/2 the height, look, notice these two lines are the parallel lines, so those were going to be our bases, and this is perpendicular to the base, so this is our height. 1/2 the height H times the sum of the bases, base 1 plus base 2. So those are the formulas for area of triangles and area of trapezoids. Okay, so let's look at example 2. So example 2 says, graph and find the area of each figure with the given vertices. So part A, we have the three vertices, -1, 1, 3, 1, and 1, 5. So that means that we're going to have to plot these points in the coordinate plane, then find the area of the figure that we have created. Okay, so let's plot the points on the coordinate plane. Okay, so let's plot our point -1, 1. So we start at the origin, x is -1, y is 1. So that will be our first point. Second point, 3, 1. So we start at the origin, x is 3, y is 1. That's our second point. And our third point, x1, y5. Sorry, x1, y5. Okay, now let's connect the 3 points and you'll notice that we have a triangle. So there we have our triangle. Now, for this one, okay, this will be our base. Okay, this line, it's our base. So let's find the height. The height, remember, that is always perpendicular to the base. Okay, that will be our height. Okay, so what will be the length of the base? The base goes from -1 to 3. So that means 1, 2, 3, 4. The base length is equal to 4. Now the height, it goes from 5 to 1. So that means 1, 2, 3, 4. Height equals 4 units. So knowing this information, now we can find the area. Area equals 1/2 base times height. Now we substitute. Area equals 1/2 times the base 4 times the height 4. So area equals 1/2 of 4. That's 2 times 4. 2 times 4. Area equals 8 square units. 8 square units. That will be the area for the figure with the vertices -1, 1, 3, 1, 1, 5. Okay, in part B, we're going to have to do the same graph and find the area of the figure with vertices at -3, -2, -3, 1, 0, 1, 2, -2. So let's graph those 3 vertices. -3, -1, -2, -3, -2. Excuse me. Wait, I forgot to write the numbers. Hold on. Okay, now, there we go. -3, x, -3, -1, -2, -3, y, -2. So -3, -2. Right here. Okay? -3, -1. -3, 1. Zero, 1. 0, 1. And 2, -2. 2, -2. Okay, so here we have our first vertices. Now we connect the points. So here we have our trapezoid. Now let's notice that this line and this one are parallel. Okay, so this would be our bases. I'll call this base 1 and base 2. It doesn't really matter how do you want to call it. If you want to call this base 1 and this one base 2, that's no problem. Now, let's find the height of this trapezoid. Notice that this line is perpendicular to base 1 and to base 2. So this could be our height. But if you're not sure, if we draw a perpendicular line, notice that this is also parallel to this, so we can consider this our height or even this. Now, let's find the length of the height. the height goes from 1 to -2. So the height will be 1, 2, 3. The height will be 3. Now, base 1. What is the length of base 1? It goes from -3 to 0. So that means 1, 2, 3. Now, base 2, it goes from -3 to +2. So that means 1, 2, 3, 4, 5 units. Now we use the formula. Area equals 1/2 the height times base 1 plus base 2. Okay? Now we substitute. Area equals 1/2 of the height 3 times base 1, 3 plus base 2, 5. Okay? Now we solve parentheses first. 1/2 times 3 times 3 plus 5, that's 8. Area equals, okay, we can use commutative property or associative property. It doesn't matter the order we multiply. So for me, it would be easier to multiply 3 times 8, that's 24. Half of 24, 12. Or half of 8, that's 4 times 3, 12. Same answer. Half of 3, 1.5 times 8, 12. Okay? 12 square units. And that will be the area of trapezoid with vertices at -3, -2, -3, 1, 0, 1, and 2, 2. Okay? So, don't forget, guys, watch the whole video. I've been noticing that you're not watching the complete video. Okay? And if you don't understand, text me and I'll try to help you with any questions that you'll have. So your homework, number 4, page 287, problems 2 through 26, even. Okay? Okay, guys. See you.